Welcome back to the deep dive.
Yeah.
Today we're going to be looking at something that affects pretty much everyone.
Yeah.
Even if you've never written a line of code in your life.
Right.
And that is defect management in software.
Yes.
We all use software.
Absolutely.
So understanding how these bugs, how these issues are handled really impacts the quality of the apps and services that we rely on every single day.
Every day, yeah.
So we've got a great piece of research here titled Defect Management in the Software Industry.
Okay.
And
sounds good.
I'm excited about this topic because, man, have I run into some buggy software
Oh, I'm sure we all have.
in my time. So to help us navigate this complex world, we have an expert here with us today.
That's right. And, we all experience the effects of software defects.
Yeah.
But most of us have no idea what happens behind the scenes to address them.
Right.
So today we're going to take a deep dive into not only what these defects are, but also who are the key players in managing them.
All right, let's unpack this. So first things first, what exactly is a software defect? Is it just anything that looks a little bit off aesthetically? Or is there like a more specific definition?
Well, it's definitely more than just aesthetics. A defect is essentially any time that the software produces an unexpected result, something that deviates from what it's supposed to do.
Right.
Think of it this way. If you hit the print button and your printer starts playing music instead, that's a defect.
Okay, that's a good one. So it's really about the functionality.
Yes.
Not just visual quirks.
Exactly.
And I guess that makes sense because those unexpected results can have some pretty big consequences.
For sure.
Imagine like a banking app calculating balances incorrectly.
Yeah, that would be a major issue. And that's precisely why effective defect management is so important.
Yeah.
It's all about identifying those bugs, understanding why they're happening, and then ultimately squashing them to ensure the software works as intended.
So who are the heroes in this bug fighting saga? Is there like a special team that's dedicated to hunting down these digital gremlins?
Yes, there is. We call them software testers. And they're absolutely essential to the entire software development process.
Wow.
They're the folks who systematically try to break the software, not out of any malice, but to find those hidden flaws before they reach users like you and me.
So they're kind of like digital detectives.
Yes.
I love it.
That's a great way to think about it.
Okay, cool. So like I'm picturing them with magnifying glasses, poring over lines of code, looking for clues.
There is definitely a lot of analysis involved.
Right.
Testers use a wide range of techniques from running predefined test cases to exploring the software in creative ways, trying to trigger unexpected behavior.
That sounds intense. Okay, so let's say a tester finds a bug.
Oh, okay.
What happens next? Do they hit like a giant red button that alerts the entire company?
Not quite.
Okay, good.
But they do meticulously document that defect in a dedicated system. Think JIRA Bugzilla. It's like creating a detailed wanted poster for the bug.
Oh, I like that visual. So what kind of information goes on this like digital rap sheet?
Well, it includes everything needed to understand and ultimately reproduce the bug.
Okay.
So we're talking a unique ID for the bug, a clear description of what the issue is, steps to recreate it, what should have happened versus what actually happened.
Gotcha.
And crucially, how severe the problem is.
Okay, so it's kind of like building a case file.
Yes.
For the developers who are going to have to fix the bug.
Exactly.
Speaking of severity, that's where I think we get into like prioritizing which bugs to tackle first.
Right.
Not all defects are created equal, right?
Absolutely not. Some bugs are far more critical than others.
For sure. Like I'd be pretty annoyed if a typo on a company's About Us page got fixed before a bug that prevents me from actually, buying something on their website.
You hit the nail on the head.
Okay, good.
We categorize defects based on their severity, which means how might they impact the software's functionality, and their priority, which is how urgently they need to be fixed.
Okay, that makes sense.
So a high severity, high priority bug would be something like a finance app that suddenly starts rounding all transactions down instead of up.
Oof. Yeah, that would definitely be top of the list to fix.
Right. On the other hand, A low severity issue might be like a misspelling in an error message.
Right.
And a low priority defect could be, say, a visual glitch in a feature that's rarely used.
Gotcha.
Something minor that doesn't impact the core functionality.
Okay, so once a bug is logged and categorized, like what happens next? Does it just kind of sit in the queue?
Well, it doesn't just sit there idly.
Okay.
It actually embarks on what we call the defect lifecycle.
Ooh, interesting.
Which is essentially a roadmap for how that bug gets from discovery to resolution.
Okay, I'm picturing a tiny little bug wearing like a hard hat, moving along a conveyor belt. Liberating process, yeah.
It's not quite that visually exciting.
Okay.
But it does have distinct stages.
Okay.
It starts as new, then gets assigned to a developer to fix.
Right.
While they're working on it, it's in progress.
Okay.
Then when they think they've squashed it, it becomes fixed. And then it goes back to the testers for retesting to make absolutely sure it's truly resolved.
So if the fix works, the bug gets to clock out and enjoy retirement.
We call that stage closed.
Okay.
But retirement isn't always guaranteed. Sometimes that fix doesn't quite work.
Oh, no.
Or even creates new problems.
Oh, wow.
And then the bug gets reopened and the cycle starts all over again.
So it's this whole back and forth between testers and developers.
It is.
It sounds pretty dynamic.
Yeah, it can be quite the dance.
Can you maybe walk us through how this might play out in a real-world situation?
Absolutely. Let's say there's a mobile banking app where users can check their transaction history. A tester discovers that some transactions aren't showing up even though they should be there.
Okay, so our tester's spidey senses are tingling.
Exactly.
They've spotted a potential bug.
Right.
What's the next step?
They would start by documenting everything in detail.
Okay.
How they found the bug, what specific transactions are missing, the steps to reproduce it.
Right.
All of this information goes into that wanted poster we talked about to create a clear picture of the problem for the developers.
So the bug report is like a breadcrumb trail leading the developers back to the source of the problem.
That's a great way to think about it.
Okay.
And from there, it's up to the developers to analyze the code, figure out what's causing those transactions to vanish, and come up with a fix.
All right, so the bug's been reported, developers are on the case. What happens next?
Well, that's where we move into the exciting world of test execution and reporting.
Ooh, okay.
And that's exactly where we'll pick up after a short break.
Sounds good. Okay, so we're back on the deep dive. And before the break, we left our hypothetical bug in the capable hands of our developers.
Yes.
Hopefully hard at work, trying to figure out how to squash this thing.
Exactly.
But, it takes more than just coding to make sure
Oh, absolutely.
that we end up with quality software in the end.
For sure.
Remember those wanted posters?
Yes.
Those bug reports that we talked about?
Right.
That's really just one piece of a much bigger puzzle.
Absolutely.
That we call test execution and reporting.
Yes, exactly.
So it's not just about finding the bug.
Right.
It's about meticulously documenting the whole detective process.
Yeah.
Right? Like imagine a crime scene report.
I like that.
But for software.
Yeah, a crime scene report for software. So there are 3 main phases to this.
Okay.
The first one we call test execution.
Okay.
This is where our software testers are systematically running through various scenarios.
Right.
Essentially, poking and prodding the software, trying to see if it behaves the way it's supposed to.
Gotcha.
If they find a defect, they document it carefully.
Okay.
So it's really about putting the software through its paces.
Yeah, it's like an obstacle course for code.
Yes. An obstacle course.
What comes after that?
So after our software has run the obstacle course, then we move into documenting results.
Oh, yeah.
And this is where detailed reports come in. Wow. We're outlining what was tested, whether each test passed or failed.
Okay.
And including any kind of evidence, like screenshots, error messages, anything like that.
Yeah, so you've got a really clear record of what happened during the testing.
Yes, exactly.
That's super important, especially if, like, the bug pops up again later on down the line.
Yeah, absolutely.
You've got this whole history to look back to.
For sure.
So what's the final stage in this reporting process?
The final stage is what we call defect reporting.
Okay.
And this is where those meticulously documented failures get formally logged into that defect tracking system.
Right, like JRA?
Exactly, like JRA.
Good.
This kicks off the defect lifecycle that we were talking about earlier, making sure that the bug is actually addressed.
Right, so it doesn't just get lost.
It doesn't just disappear.
In the digital abyss.
Exactly.
So it's like a full circle.
Yeah.
You discover the bug.
Right.
You meticulously document it.
Right.
You report it, and then ultimately it gets fixed.
It gets fixed.
So can you give us a real-world example
Sure.
of how this might play out
Yeah.
in like a real app?
Let's say we have a travel booking app.
Okay, I like it.
Our tester is going through the process of booking a trip.
Mm-hmm.
They get to the payment page.
Yep.
They hit confirm booking, and nothing happens.
Ugh, I've been there.
I think we all have.
It's so frustrating.
Yes.
Especially when you're trying to book
When you're ready to go.
a flight or a hotel.
Yeah, you've got your bags packed.
Yeah. So what does our tester do in this scenario?
So our tester would document exactly what happened,
Okay.
what specific button they clicked,
Uh-huh.
the lack of response, any error messages or lack thereof.
Right.
They might even record a video of the process
Oh, wow.
so that they can show the developers exactly what went wrong.
So they can see it.
Yep, so they can see it.
So it's all about creating a really clear,
Yes,
foolproof record of the bug.
a foolproof record.
What if this isn't a completely new bug, though?
Okay.
What if it's like something that's been fixed before, but it's somehow resurfaced?
That's a great point, and that happens more often than you might think.
Really?
Yeah, in that case, the tester would actually link the new bug report to the old one,
Oh, wow.
providing valuable context for the developers.
Okay.
So they can
So they know.
if the original fix was just inadequate, or if something else is causing the same problem to come back again.
So it's kind of like detective work.
It is. It's detective work, but with code.
But with code, yeah.
Exactly.
You're looking for patterns, you're connecting the dots,
Yeah.
trying to understand why this bug is back to haunt us.
Exactly.
This is all really fascinating stuff.
Yeah. It's pretty cool.
So that kind of thinking, right? Where you're looking at past bugs.
Yeah.
You're trying to figure out what's going on.
Right.
It leads us to the more advanced strategies
Yes.
that companies use
Exactly.
to manage defects.
That's where we're headed next.
Okay, cool. So we're not just reacting to bugs anymore.
No.
Now we're trying to prevent them altogether.
That's right. We're going to get proactive.
I love that.
And we're going to dive into those approaches
Okay.
right after this.
Okay. So we're back and ready to dive into these proactive strategies
Yes.
that companies are using to prevent bugs.
Exactly. Yeah.
So earlier we were talking about this idea of like building a fortress of quality.
Fortress of quality, yes.
Around our code.
Yeah.
To keep those bugs out.
Absolutely.
What kind of strategies are we talking about here?
Well, one approach that's becoming really popular is something called shift-left testing.
Okay, shift-left testing, what is that?
So traditionally, testing was done at the very end of the development process.
Okay, so right before release.
Exactly. But with shift-left testing, the idea is to integrate testing much earlier in the cycle.
Oh, I see. So instead of testing being this last hurdle before you release the software, it's kind of woven into the entire process.
Yes, it's woven throughout.
Okay.
And by involving testers from the get-go, companies can catch potential defects much earlier.
Right, because the earlier you catch them,
Absolutely.
the easier it is to fix them.
Much easier and generally less expensive.
Oh, okay.
Yeah.
So it's kind of like catching a typo in the first draft of an essay.
Exactly.
Versus like finding it.
Yeah.
After the essay's already been printed and bound.
I love that analogy. That's perfect.
Yeah, you don't want to have to reprint the whole thing.
Exactly. You don't want to reprint the whole thing.
Okay, cool.
So shift-left testing often goes hand in hand with automated testing.
Okay, what is that?
So with automated testing, you're using software tools to run repetitive tests automatically.
Okay, so instead of having like a human tester do the same thing over and over again.
Exactly.
You have a program do it.
Yes, exactly.
Okay.
This obviously saves a ton of time.
Right.
But it also ensures consistency.
Okay.
And it frees up those human testers
to
focus on the more complex scenarios that require, a human touch.
So it's about working smarter, not harder.
Absolutely. Working smarter, not harder.
Okay, that makes sense.
And speaking of the human element, another key aspect of defect prevention is fostering a culture of quality within the development team.
So what do you mean by that?
So it's not just about individual developers writing perfect code.
Right.
It's about the team as a whole taking ownership of the quality of the product.
Working together.
Exactly. Working together, collaborating, communicating openly, and sharing a sense of responsibility for delivering high-quality software.
Gotcha. Are there any, specific techniques that teams use to kind of build that culture?
Yeah, one really effective technique is something called code reviews.
Okay, code reviews.
Where developers essentially review each other's code.
Oh, interesting.
For potential errors, vulnerabilities, anything that could lead to defects.
So it's like a second set of eyes.
Yes. A second set of eyes, or even multiple sets of eyes.
Right.
Scrutinizing the code and making sure that nothing slips through the cracks.
And that's also a great way, I imagine, for knowledge sharing.
Oh, absolutely.
Within the team.
Definitely.
So people can learn from each other.
For sure. Learn from each other's mistakes, share best practices, all of that.
So it's not just about finding the bugs.
Right.
It's also about learning and growing as a team.
Exactly.
And ultimately building better software in the future.
Right. That's the goal.
This has been a really amazing deep dive.
I agree.
We've gone
I've heard a lot.
Wanted posters for bugs to this intricate dance between testers and developers.
Right.
And now we're talking about these really proactive strategies for building quality into the software.
Into the process from the very beginning. Right. And that's really the key takeaway.
Right. It's not just about fixing bugs.
No.
It's about preventing them in the first place.
Exactly.
And creating better software for everyone.
Absolutely. And creating a better experience for users.
Well, on that note, I think that about wraps up our deep dive.
Yeah, that was a great conversation.
Into defect management. Thank you so much for joining us.
My pleasure. It was great to be here.
And thank you for listening.